Hi everyone, welcome to my Stats 1 OCR June 2011 paper. We're going to look at question 8, which is the last question. We've got 4 guys playing a game. We've got Anne, Bill, Chris and Deepak. They've got a cuboid dice, okay? Cubical dice, which is just another way to say a normal dice. For some reason they've chose to say that. So, you've got normal dice, and you've got the guys playing. They take it in turns, and look at that. Their names are beginning with A, B, C, D. Isn't that a coincidence? Or has the examiner set it up nicely for you? Who knows? So they take it in turns, starting with A. We're going to call Anne A, etc., etc. Then B, then C, then D. And they carry on taking it in turns in this way until somebody gets a 6, and then it's the end of the game. If you do fancy playing this game, grab yourself 3 friends and a dice, have a go. So, when they get a 6, they stop the game, they've had their fun, game over, okay? So, Chris wins on his first throw is the first question. So if we number these turns, first, second, third, etc., this is our game. And we are going to call X the number of times that they get to roll the dice between them, okay? Now X comes from a geometric series, a geometric distribution, because the game is stopped when the first person gets a success, which we're calling getting a 6. And the probability of getting a 6 on a normal dice is 1 in 6. So P is a 6th, and Q, the probability of failure, not a 6, is 5 over 6. So, on with the first question. The probability, Chris wins on his first throw. Well, we've got fail, fail, and then success. So it's going to be Q squared times P, aka 5 over 6 squared times by 1 over 6. And if you put that into your calculator, you're going to get 25 over 216, which is an okay fraction, so we will leave it like that. Part 2. Deepak wins on his second throw. So let's look on the diagram where we're up to. On his second throw, first throw, second throw, we want to win here. So we need to think that we've had 7 failures, so Q to the power of 7. And then 1 success times P. So that's going to be 5 over 6 to the power of 7 times by 1 over 6. And as a decimal to 3 significant figures, 0.0465. On part 3, we want Anne to get a third throw. So if we look at her throws, there's a first one, second, third. As long as she's had 3 turns, she's happy. It doesn't say that she has to succeed or fail on this turn. In fact, we don't really care. We don't care anything after the 9th turn. Okay, so the probability of all this, if anything can happen, is going to be 1, because something's going to happen. They're playing the game. So we need to think back and think that all we care about is all these probabilities. Okay, and if we look, there's 8 turns and they all have to be fails, so it's going to be Q to the power of 8, which is going to be 0.233. So for part 4, it gets a bit more tricky now. We are looking at wanting Bill to throw the dice exactly 3 times. So we want to think on the diagram when Bill has thrown it exactly 3 times in the game. So let's label it up. The first throw here, he's had 1. He's had 2, exactly 3. So this one could count. Here, when it's Chris's turn, he's still had 3 throws. Bill has. Okay, so all these 4 options are what we're interested in. As soon as he goes beyond, he's had 4 turns, and before he's had 2 turns. So we want to find a way to find the probability of this thing. Obviously you can just add them all up and get the probability, but I'm going to show you a slightly different way. So I'm going to be looking at the probability that x is greater than or equal to 10 and less than or equal to 13. Now if we think about what we've been doing previously, we can split this up and we know that the probability that x is greater than or equal to 10 is going to be just q to the power of 9. So we're going to figure that out in a second. X is greater than or equal to 10. And now we want to think about as well the probability that it's greater than 13. Now if we check out this option here, what we've just said, q to the power of 9, gets you everything in there carrying on forever. Okay? We don't want it carrying on forever. We actually want to get rid of all the things here. So we want to get rid of anything that is greater than or equal to 14. Okay? So what we're going to do is q to the 9, take away q to the 13 from your formulas. So that's going to be 5 over 6 to the power of 9. Take away 5 over 6 to the power of 13. If you put it in your calculator to 3 significant figures, you get 0.100. Hope this has been helpful, and you've learnt a nice fun game for you to play with your friends, so it's a double win. Thank you very much.